Okay, so for this little chunk, we'll go through a couple of numerical methods, some of the built-in functions for Excel, and also thinking through just some of the most basic methods that are used, the Newtonian and bisection methods. One of the simplest tools to use is GoalSeek. You can find that up in the Data tab under What If Analysis and GoalSeek. This is what it's going to look like when it pops up. So it is used when you have one equation where you only have one value that you need to manipulate. So if you have, I don't know, 3x squared plus 2x plus 5 equals 0, and you want to find out what value of x would work for that, then what you would do is put your equation into a cell, set your start cell, tell it what you want value to go to. So if you want it to solve to 0, and then the cell that you're going to change is that value for x that goes in the function. Okay, just some examples of why you'd want to use that. So some equations are very simple. You could analytically solve it. Other equations are a little bit more clunky to solve analytically, and maybe you just want to do some kind of a generic situation where you can throw anything into it and not have to figure out what method to apply to what. So a lot of times the numerical methods are just a faster, more efficient way to solve for something than to go through all of the different ways to analytically solve something. And then, of course, there are some equations that there are no analytic solutions to. So the only thing you can do is some kind of numerical solution or graphical solution. Okay, so let's go ahead and take a couple of different scenarios. This first scenario, we should only have one solution for. This next scenario, if you get something like a sine or a cosine wave, then you have multiple scenarios. And you have to start thinking about what should I start my value with and how is that numerical method working under GoalSeek, and realize that there's different answers that can come out of that thing depending on what you put into it. Okay, so I'm going to go ahead and grab my snipping tool and we'll try out a couple of equations in Excel. So the first one we'll do is this x to the fifth, which would be kind of hard to solve that by hand. And we'll just start with a blank Excel sheet. One thing that is nice to do before using GoalSeek is to graph this out. So the graph will tell you at least what range of values we should start looking at. So if you've done an XY scatter graph, X, whatever goes on the X-axis, that's usually what you put in your first column over here. And then your function for the X-axis, that's what we're going to put over here next. And for X, we don't know what that is. And so you have to just kind of start somewhere. So let's just randomly start. And I can change what numbers I'm plugging into this later. So if I graph it out and I notice that, wow, this is actually not going through 0, so I didn't grab the right range, my solution is not between -10 and 10, then I can go back and change this. But just randomly start somewhere. And then over here, I'm going to type in this equation. Let me zoom in a little bit here. Okay, so I'm going to type in my equation, and every time I see an x in this equation, I'm going to click on that value of x in my x column here. So there's my x to the fifth minus 3 times x cubed. And it's really easy to type the equation in wrong. So before you hit enter, really look at that and make sure, did I get that in there right? Okay, so there's my function, and wow, we're starting with a really big negative number there. So double click and it'll copy it all the way down. And then we want to just see what's going on. So I'm going to go ahead and insert just a good old XY scatter plot. So might be interesting to add a trend line to that and see how well Excel is able to put a trend line. Shall we try it? Just out of curiosity. So Excel actually does have a polynomial trend line. Let's go ahead and just out of curiosity, add trend line. And we'll put on a polynomial, 3, 4, 5, and look at that, nice perfect fit. So we're going to display equation on chart, display our squared value. Let's see how close this looks to the equation we typed in. 1 times x to the 5th, and then pretty much 0. 6 times 10 to the negative 11th, that's 0 times x to the 4th minus 3x cubed. And pretty much 0 for x squared. So that's pretty, Excel did a pretty decent job, right, of redoing that equation. It's not exactly the same, and you can see, I think Excel goes out to like 15 decimal places or something, and so there are some rounding errors there, but that equation that the trend line gave us is pretty darn close. Yeah, because that 4th term is pretty much 0 and the squared term. So that's kind of neat. Okay, but that does show us that it's going to go through 0 somewhere between negative 10 and 10. So we have somewhere to start with. And it also looks like we're only going to have one solution for this equation too. So that's a good thing to know too. Okay, so now that we have it graphed and we understand a little bit better about what we're dealing with here and where our solution is supposed to be, now I'm going to set it up for goal seek. So for goal seek, I'll put x, just one value for x, and this is a starter value. So if I look at this chart, a good place to start, I don't know, maybe right there in the middle, right? So let's go ahead and plug in what if x was equal to 0? And then I'll go ahead and put my equation in here next. And if I use this value for x, my equation is not going to add up to 0. It's going to add up to something different. But my goal seek is going to change. So this is what's going to change. See, goal seek will change this cell. And then as the numbers in this cell change, the equation. So we're going to just keep changing this x value, and the equation will keep calculating what it is, and that the point of this is to try and change x until we get to our goal, which in this case will be 0. So I'm going to put that equation in again. So equals x to the 5th minus 3 times x cubed plus x minus 1. Okay, one last check. Make sure we've got that in there right. So 3x cubed. So there we go. And you notice that that is not equal to 0, and that'll be the goal. Okay, so we're going to go ahead, go over to Data, What If Analysis, Goal Seek, and our starting cell is the cell that we just typed that equation into, and we want that cell to eventually calculate the number 0. Okay, if we have the right value of x in, we'll end up with a 0 over there. So we're going to change this cell, and hopefully we can get down to 0. So let's hit OK. When I do this, watch this value of x. You can watch it change as it tries to find the solution. So it's going. Oh, yay! Okay, so this is pretty. It says, is that close enough? 6 times 10 to the negative 5th. If it doesn't stop itself after a number of iterations, it'll just keep going and going for infinity, right? So at some point you have to call it close enough. So yeah, that's pretty much 0 there. And x equals 1.69. That looks like a pretty good value. So then if I were to redo my range here, so maybe -2. Yeah, let's start it at 0. Maybe a short little. So we'll just change the range from our graph here so that we can kind of zoom in on that answer a little bit more. And it's, yeah, that's really hard to see, I guess, right after 2. I'm going to go ahead and Yeah, things really take off there after 2. So let's go ahead and look at the answer here. Oh, and it looks like 1.6. So see how that line is really coming through the 0 point. So 1.69, here's 1.5, so 1.6. That's where it's really coming through. And that's, yeah, zooming in on one range versus another. And you can just grab this little corner here and kind of redo what range you're looking at. And you can redo the step size here to zoom in on something. This is kind of an interesting graph. You almost want to see what that is a little bit farther out. So it is a good idea to study those graphs. Make sure that there's only one solution, because a lot of these times you'll think you have it and then you realize, oh, actually there's kind of more than one solution going on. So play around with that graph and try out the sine x one too, and do the same thing where you graph it out, and that one will have 2 solutions. So play around with this. You can copy and paste it over here and try a different scenario. So maybe I start one at positive 10, maybe I start this one at negative 50 or something, right? And then I do the same thing again. So if I start it at a completely different place, what will that end up bringing it to? So the same thing right now, negative 3 times 10 to the 8th, it's like a huge thing. So this might not get as close this time around. It's trying. Well, negative. So that's not quite there, but that's definitely a different answer than we got before. So yeah, you really need to combine this goal seek method with looking at your function on the graph, because otherwise you could be starting in the totally wrong place to solve it, and you could get something that's not really. But if you combine it with looking at the graph, you can get some decent answers out of it. Okay, so that's goal seek.